Hello, it is finally time to learn how to multiply mixed numbers and fractions. And we of course are going to start with everyone's favorite, the area model. And just my disclaimer, this is part of the standards. I do have to show you how the area model works. Yes, I will show you the shortcut that everyone at home wants you to know, I promise. But I want to show you how that shortcut came about so that you have a visual model reminder of it and you have a true understanding. So area model is basically like when you have a rectangle, you take length times width, right? So if I gave you a rectangle and I said this rectangle is 2 units by 3 units, what's the area? Later you learn, oh, I can just do 2 times 3 and that equals 6. When you first learned this, you actually sectioned it off. And if this was 3 up here, that meant it was 3 sections in length, and this along the side meant 2 sections in width. And to get that 6, we counted the number of squares in this 3 by 2 rectangle. 1, 2, 3, 4, 5, 6. That is the area model. But now, instead of taking 2 times 3, we're going to take 1 2/3 times 3/4. But we're going to use this same model to help us. It's like the length times the width, okay? And this is very similar to when we multiplied a fraction by a fraction, except 1 2/3, we're going to have more than one whole amount. So you don't have to draw anything perfect right now. It's okay. You don't need a ruler or anything unless you really want one. Just do your best. And I'm going to suggest that you grab a pencil and 2 different colors of colored pencils or crayons. I'm going to use my favorite colors, yellow and blue. So just don't use green. Use yellow and blue. But honestly, any 2 different colors will be fine. So I want to build a rectangle that is 1 2/3 by 3/4 so I can find the area of it. When I built a rectangle that was 3 units across, we had 3 units across, right? 1, 2, 3. So 1 2/3 means I'm going to have 1 hole. So draw 1 nice big square. This is 1 hole. But this first amount is not just 1 hole, it's 1 2/3. That means I need 2/3 of another hole. So I'm going to draw another square that's about the same size as that one. I want them to match, but I only need 2/3 of this one. So I'm going to draw my lines, and now I'm going to shade in 1 2/3. So this is 1 hole, this is 1 hole, but I only need 2/3 of this one. So I'm going to shade this one in blue. Why not? You shade it whatever color you want. So here's the 1 hole, and then I need 2/3 of another. Okay? So from here to here, this is 1, and this is 2/3. And together, they make 1 2/3. So far I have 1 2/3 going across, kind of like I had my 3 there. Now when I had my 2 on the side, I cut this up into 2 pieces. Right now we want to multiply that by 3/4, so I need 3/4 along the side. So I have 1 hole, right? I only need 3/4 of that hole. That means I'm going to cut this up into 4 sections. And I need to shade in how many of those sections? 3, because I have 3/4 of this. So along this side, I will shade in 3 out of the 4, 1, 2, 3, 4 pieces. So this piece right here is 3/4. Okay, so when we had the 2 by 3, it was the number of squares that were within these side lengths boxed in, right? When you look at this, my answer is the double shaded part because that's in the dimensions of 1 2/3 by 3/4. So this is where my answer is. I'm trying to get the highlighter out and see if that helps a little bit. It's the double shaded part. And I'm not including this little chunk in my answer because the 2/3 stops there. My rectangle is this. These are just the extras that were helping me when I was dividing it up to get my fractional amounts. Okay, so when you give me a fraction, you're supposed to tell me the number of parts out of the whole amount, right? So this is kind of hard to see, isn't it? Because the pieces aren't the same size. So what we should really do is make sure we're dealing with pieces that are the same size. So the way we can do that, you know how we cut this hole up into thirds? Let's cut this hole up into thirds as well. Now I'm dealing with pieces that are all the same size. So to get my numerator, I can count the number of double shaded pieces. 1, 2, 3, 4, 5, 10, 15. So 15 pieces are double shaded. My denominator is how many pieces the whole is broken up into, right? This giant chunk here, this is 2 whole squares. 1 whole square is broken up into 3, 6, 9, 12 pieces. My denominator would be 12, not 24. There's 24 pieces in 2 whole, but there's only 12 in 1. So we get 15/12 as an answer, and yes, we can simplify that further. I know that 12 goes into 15 one time, and there's 3 12ths left. And I also know that 3 and 12 can both be divided by 3. So 1 and 1/4 should be your final answer for that. Okay, let's look at our next one. Next one is 1 2/5 times 1 1/2. So same kind of thing. I'm gonna draw my 1. So draw a nice big square. And then I want 2/5 of another. So I'm gonna draw another square that's the same size, but I'm gonna cut it up into 5. And to show 1 2/5, I would color in this whole big square, this one whole, and 2/5 of the other. So right now, I have my 1 plus I have my 2/5. Now along this side, I'm supposed to have 1 1/2. Now last time when I had 3/4, 3/4 is less than 1, so I just took that 1 and cut it up into 4 pieces. Now I have 1 1/2. So along this side here, I need it to be 1 1/2. That means I actually need another whole square here. Yep. Now, because it's area, we know that we wouldn't leave it like this, right? We would fill in the entire thing. Just like for 3 by 2, I didn't leave these empty. So you can draw in another hole so that it all matches up so that we're still dealing with a rectangular shape here. But along here, I need this 1 right here, and I need half of this. So that means I'm gonna draw my line here, and I only need to shade this half, right? So I'm gonna shade 1 1/2 now. So I'm gonna go ahead and shade in that, and shade in that. Okay, so right now I have 1 2/5 times 1 1/2. Now my answer here is going to be, and I know it's a little trickier because we colored this in before, but are you noticing that this side goes all the way down? My rectangle here is actually this big chunk. So I'm looking for my answer in here because this is 1 2/5 by 1 1/2. So remember when we get our answer how we need to have same size pieces? It looks to me like we've got some work to do, right? Because these are not the same size pieces at all. So first off, going across here, it looks like this is broken up into 5ths, right? So let's extend our line down and let's break up this into 5ths as well so that at least those match. So 1, 2, 3, 4. Okay, so now we're close, but do you see how these pieces are only a half of a unit tall and these are 1 whole unit tall? Let's break this section up so the halves match. Okay, so now our answer to this, now that we're dealing with all these same size pieces, is in this rectangle right here that is 1 2/5 by 1 1/2. So let's count our pieces so we know what our numerator is. I see 1, 2, 3, 4, 5, 6, 7, 14, 21. And remember here that our denominator is how many pieces the whole is broken up into. Now, if you look at this right here, this represents 1 whole, 1 square. And this is broken up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So the answer to this would be 21/10 because 21 pieces are shaded out of 10 pieces in that whole. That means my answer should be 10 goes into 21 twice with 1 left over out of 10. So 2 1/10 should be your answer. Okay, are you ready for me to show you how they came up with the standard algorithm and what to do? I'm sure you're quite ready. You're like, do we really have to do this? Do we really have to understand this picture? Yes, you do. So when we had 1 2/3, remember that we broke this up so that I could have the same number or the same size pieces? When we broke this up into 1, 2, 3, 4, 5, and isn't each one of these 1/3? So 1, 2, 3, 4, 5/3 by 3/4. So 1 2/3, is 1 2/3 the same as 5/3? Yup. 3 times 1 is 3 plus 2 is 5/3. So you can change this mixed number into an improper fraction, right? And then just take the 5/3 and multiply it by the 3/4. That's what we did. And 5 times 3 is 15, and 3 times 4 is 12. Yes, my friends, all you have to do is change your mixed numbers into improper fractions, and then you can multiply them the same way that we have been doing for the last 2 weeks. We can cross simplify when we can, and multiply our numerators, multiply our denominators, and simplify. So it works for this one too. I'll show you. 1 2/5, 5 times 1 is 5 plus 2 is 7/5, times 2 times 1 is 2 plus 1 is 3/2. I can't cross simplify anywhere. 7 times 3 is 21. 5 times 2 is 10. We can't just say 1 times 1 is 1, and 2/5 times 1/2 is 2/10, which is 1/5, and 1 1/5. This area model shows you can't just multiply these digits like that. This actually means 1 plus 2/5 times 1 plus 1/2. So change them to improper fractions and then use your same rules. And that's what we're going to fill out down here. When multiplying mixed numbers, change the mixed number to an improper fraction. That's why we've been doing that in our bell work all week. Then you can multiply multiply the numerators and the denominators as you did before. I know, it's amazing, right? So when you see problems like this, we're just gonna go ahead and say, okay, I have a mixed number times a fraction. I'm gonna change this to improper. And these are the ones we just did. 3 times 1 is 3 plus 2 is 5/3 times, I don't need to change that, it's already set, 3/4. But now when we see this, we can recognize, hey, wait a minute. I have the digit 3 diagonal from one another. 3 is a GCF of 3. 3 goes into 3 once. 3 goes into 3 once. 5 times 1 is 5. 1 times 4 is 4. And yeah, 5/4, that's improper, would become 1 1/4, which is exactly what I got right here. And our second example for 1 2/5, 5 times 1 is 5 plus 2 is 7/5, times 2 times 1 is 2 plus 1 is 3/2. Now I can't cross simplify there and I can't cross simplify there. 7 times 3 is 21. 5 times 2 is 10. All right, so 10 goes into 21 2 times, 1 left over out of 10. It really works, and you have the area model to prove it. We're going to do the second page of the notes tomorrow because honestly, I think 14 minutes of really focused attention is probably good. So thank you very much for completing your notes. Get ready to do a little bit of practice.